Here we have a solid state Tesla coil. Out of the top there's a wire that comes down into this plastic tube and stretches out for some distance. On the other side of the tube we've put a little bar of aluminium, 5 millimeters thick, and we want to see whether we can make a Jacob's ladder current sideways between the AC power from the Tesla coil and the aluminium bar, which simply acts as a ground. There's no second negative electrode. Into the tube we're going to feed this argon gas from a cylinder like that, and we can also add a big chunk of aluminium as a second ground to see whether that influences things. Let's turn on the power now and see what happens. When we turn on the power very weakly, you can see a little tiny arc of argon gas forming between the wire and the side of the tube. That's only at 17 watts. Let's turn the power up now and see what happens with a little bit of argon gas flowing through the tube. Now we've got a Jacob's ladder forming at 40 watts. If we increase the ground, then it becomes even more energetic. Now I've turned off the light so we can see it more clearly. This is a low value, tiny little spark at about 18 watts. When we turn up the power to 30 watts, then we see the Jacob's ladder really take off. So this is based just on one electrode, AC power from the Tesla coil, and the aluminium is just a ground. We don't have a second negative electrode. This is therefore Jacob's ladder based on AC power at high frequency and only one electrode.